Now we're going to talk about horizontal shrinking. Let's take a look at some different horizontal shrinks and see what that looks like graphically. First of all, we have f of x equals 2x squared. So here is f of x equals x squared. We're going to put a value of 2 in front of x and still square that quantity. Now here is our parent graph. Let's see what happens when we put a 2 in front of the x. So notice that the original graph is wider, okay? The new graph f of x has shrunk horizontally and become more narrow. Now again, this is a little counterintuitive. We would think that if we put a number bigger than 1 in front of x, that it would stretch out, but it doesn't. So this goes kind of alongside the horizontal shifting. When you have x plus 2, for example, it shifts to the left and vice versa. And we want to figure out why that is. Now we're going to look at f of x equals sine of 2x and f of x equals cosine of 2x. Let's go ahead and pull up sine. Now again, we're going to take our b value, which is originally 1, and we're going to put a 2 in front of it. And zoom in a little bit so we can see what's going on. So this one really shows you, it's kind of like a spring, okay? We can see that the spring becomes crunched. It becomes compressed when we make b equal to 2. The same thing is going to happen for cosine. As the b value gets bigger, that spring compresses more for our transformed function from our purple parent function. There's our parent function, cosine of x. Our transformed is cosine of 2x. So we want to get to the bottom of this. Why does the 2 in front of the x cause a horizontal shrinking? You could also call it a compression. Let's take a look at that algebraically. We can see that when b is 2, the parent graph shrinks horizontally in half. But why? So we didn't actually talk about that, but in fact it is shrinking in half. We have kind of covered it in trig. We know that the period of the parent function cosine is 2 pi, and the period of our new transformed function is pi. That's half, right? So we can see that compression is cut in half if we think of it in those terms. But let's look at it algebraically why. Let's go back to our x squared function. Okay, so we know that p of 1 is going to be equal to 1. How would we get the same y value for our transform function, knowing full well that we need to end up with 1? How do we know what our x value is going to be? Now it's going to be 1/2. It's going to be half of this x value, but the question is why? So p of 1 is 1. Again, like we've done before, we want the input of our transformed function to also be 1 so that we can get 1 back. In order to accomplish that, we would actually have to multiply we'd have to make x equal to 1/2 because 2 times 1/2 equals 1 to get the same y value back. This illustrates that our x value has been cut in half in order to achieve the same y value of 1. Therefore, the horizontal shrink is half. 1 times 1/2 equals 1/2. Okay, we could look at a different x value, say 3. If we plug in 3 to our original x squared function, we get 9. What would we have to plug in for x for our transformed function, f of x equals quantity 2x squared, in order to get 3 back? Well, we'd have to multiply by 3/2. In other words, we'd have to multiply by, we want 3, right? But we'd have to multiply by 3 over 2 to cancel these 2's out from this b value of 2. That would give us the same x value of 3, which would give us the same y value of 9 back. So let's look at that on our graph. We're going from 3 to 3/2. Now remember, 3/2 is just 1.5. So let's zoom out here a little bit. P of 3 is 9. In order to get the same y value for a transformed function of 9, we'd have to plug in 1.5 or 3/2. And again, this is algebraically why it's true. Another way to show this is actually an algebra problem. We want the same input for f of x as we did for p of x. That will guarantee that we get 9 back. So set 3 equal to 2x. And by dividing by 2, we can see the horizontal shrink visually. To get this x value that we want for f of x, we divide by 2. Dividing by 2 is the horizontal shrink. So take whatever the x value was for the parent function and divide by 2 to get the new x value that we want, 1.5. If we plug in 1.5 into our transformed function, it'll be the same as if we plug in 3 for our parent function, Because 1.5 is 3 halves, and 3 halves cancels that original 2 out that we put for our b value, and we get 3 back, the same 3 that we got in for a parent function. They both give us a y value of 9. Again, we can see that visually here. P of 3 is 9, and f of 1.5 also gives us 9 back. That's it for this video of why 2 causes a horizontal shrink in half. If you have any questions about it, let me know.